Imagine a time before time existed. No space, no matter, no light. Then, about 13.8 billion years ago, everything changed. A tiny point, smaller than an atom, contained unimaginable energy. This point, called a singularity, suddenly expanded. This is the Big Bang. The Big Bang wasn't an explosion in space, it was the expansion of space itself. Imagine a balloon with dots on it. As you inflate the balloon, the dots move apart, just like galaxies in our expanding universe. The universe cooled as it expanded, setting the stage for the formation of everything we see today. In the first fraction of a second, the universe was incredibly hot and dense. It was like a cosmic soup of energy, constantly transforming. As the universe cooled, this energy started to condense into particles. Think of steam cooling and forming water droplets, but on a much grander scale. These weren't the particles we know today, like electrons and protons. These were exotic, short-lived particles that existed for mere fractions of a second. The universe was a chaotic dance of creation and annihilation as these particles collided and transformed at unimaginable speeds. But slowly order began to emerge from the chaos. As the universe continued to cool, the familiar particles we know today began to stabilize: quarks, electrons, and their antimatter counterparts. These particles are the building blocks of everything we see around us. The universe was still incredibly hot, a seething mass of these particles constantly interacting. Slowly, the universe cooled enough for quarks to combine and form protons and neutrons. This was a pivotal moment in the universe's history, the creation of the building blocks of atoms. The universe, once a sea of energy and exotic particles, was starting to resemble the one we know today. For hundreds of thousands of years after the Big Bang, the universe was filled with a hot, dense fog of hydrogen and helium gas. Light couldn't travel freely, it was constantly scattered by the dense gas. Gravity slowly pulled these gases together into massive clouds, denser and hotter than the surrounding space. Inside these clouds, the temperature and pressure became so intense that hydrogen atoms began to fuse, releasing enormous amounts of energy. The first stars were born. These stars were massive and short-lived, but they changed the universe forever. They flooded the cosmos with light and created heavier elements like carbon, oxygen, and iron in their cores. These first stars, known as Population 3 stars, were unlike any stars we see today. They were composed almost entirely of hydrogen and helium, with virtually no heavier elements. This lack of metals made them burn hotter and faster, leading to their relatively short lifespans. When these stars exhausted their nuclear fuel, they ended their lives in spectacular supernova explosions, scattering the newly formed elements across the universe. These supernovae were so powerful that they triggered the formation of new stars and galaxies, seeding the cosmos with the building blocks of planets and life. The light from these first stars also played a crucial role in reionizing the universe, transforming it from a dark, opaque state to the transparent cosmos we observe today. This epoch, known as the Epoch of Reionization, marked a significant turning point in the evolution of the universe. The birth of the first stars set the stage for the complex and diverse universe we inhabit. Their light and the elements they created paved the way for the formation of subsequent generations of stars, planets, and eventually, life itself. The story of the first stars is a testament to the transformative power of stellar processes and the interconnectedness of cosmic events. As we look up at the night sky, we are witnessing the legacy of these ancient pioneers. Their light, traveling across billions of years, reaches us as a reminder of the universe's dynamic history and the ongoing cycle of creation and destruction that shapes the cosmos. The first stars ignited a chain of events that continues to unfold, influencing the structure and composition of the universe. Their story is a fundamental chapter in the grand narrative of cosmic evolution, illustrating how the simplest elements can give rise to the most complex structures. Section 5. Galaxies, islands of stars in the cosmic ocean. These magnificent structures are the building blocks of the universe, each one a collection of billions, sometimes even trillions of stars. They come in various shapes and sizes, from the elegant spirals like our Milky Way to the more chaotic and irregular forms. Gravity continued to shape the universe, pulling together vast clouds of gas and dust. These clouds, known as nebulae, are the birthplaces of stars. Over millions of years, gravity causes these clouds to collapse and condense. Within these clouds, stars ignited, forming massive clusters held together by their mutual gravity. These star clusters can be found throughout galaxies, acting as cosmic nurseries where new stars are born. These were the first galaxies, vast islands of stars, gas and dust. Each galaxy is a dynamic system, with stars orbiting around a central core, often containing a supermassive black hole. Our own galaxy, the Milky Way, formed around this time a swirling disk of billions of stars. The Milky Way is a barred spiral galaxy, with its stars, planets and other celestial objects orbiting the galactic center. Within galaxies, smaller clouds of gas and dust continue to collapse, giving birth to new generations of stars. This process of star formation is ongoing, with new stars being born even today. The universe was no longer a uniform fog, but a tapestry of light and darkness, with galaxies scattered across the vastness of space. Each galaxy, a beacon of light in the cosmic ocean, contributes to the grand mosaic of the universe. The study of these galaxies helps us understand the history and evolution of the cosmos, revealing the intricate dance of matter and energy that has shaped everything we see today. Section 6. A solar system is born, our place in the cosmos. About 4.6 billion years ago, in a relatively quiet arm of the Milky Way, a cloud of gas and dust began to collapse. This cloud, enriched with the remnants of previous generations of stars, contained all the elements necessary for life. At the center of this swirling cloud, a star ignited, our Sun. Around the young Sun, the remaining gas and dust swirled, forming a disk. Over millions of years, particles in this disk collided and stuck together, gradually growing larger. These clumps became planets, asteroids, and comets, forming our solar system. Section 7. The Expanding Universe, a Never-Ending Story. In the 1920s, astronomer Edwin Hubble made a groundbreaking discovery. The universe is expanding. Hubble observed that distant galaxies are moving away from us, and the farther away they are, the faster they are receding. This doesn't mean we are at the center of the universe. It means space itself is expanding, carrying galaxies along with it. Imagine baking a loaf of raisin bread. As the bread rises, the raisins move farther apart. Similarly, as the universe expands, the space between galaxies increases. This expansion has continued for billions of years and shows no sign of slowing down. Section 8. Dark Matter and Dark Energy. The universe's mysterious architects. While studying the rotation of galaxies, astronomers noticed something strange. Galaxies were rotating faster than they should be based on the visible matter they contained. This led to the hypothesis of dark matter, an invisible form of matter that interacts gravitationally, but doesn't emit light. Furthermore, the expansion of the universe isn't constant, it's accelerating. This acceleration is attributed to dark energy, a mysterious force that counteracts gravity and pushes everything apart. Dark matter and dark energy make up the vast majority of the universe's mass and energy, yet we know very little about their nature. Section 9. The universe, a tapestry of time and matter. It is a vast expanse that stretches beyond our imagination, filled with wonders and mysteries that have captivated humanity for centuries. From a tiny point of unimaginable energy known as the Big Bang, the universe burst into existence. Over billions of years, this initial explosion gave rise to the complex structure we see today, with galaxies, stars and planets forming in a delicate dance of gravity and time. From the first stars that ignited in the darkness, to the majestic galaxies that swirl in the cosmic ocean, from the birth of our solar system with its planets and moons, to the ongoing expansion of the cosmos that continues to this day, the universe is a story of constant change and evolution. It is a dynamic tapestry woven with threads of time and matter, each moment adding a new layer to its intricate design. We are part of this grand cosmic story, our very existence a testament to the intricate processes that have unfolded over eons. Every atom in our bodies was forged in the heart of a star, connecting us to the cosmos in a profound way. Our journey through time is intertwined with the universe's own evolution. As stars are born, live and die, they create the elements that make up everything we know. As we continue to explore the universe, we uncover more about our origins and our place in the grand scheme of things. Each discovery brings us closer to understanding the vast interconnected web of existence. Through the eyes of our telescopes and the data from our probes, we peer into the depths of space, revealing the secrets of distant galaxies and the fundamental forces that shape our reality. The quest for knowledge drives us forward, ever curious,